Hello, humans. What you are about to hear is not science fiction. It's a hypothesis, but a hypothesis built on real experimental results. Marsio Salcuni has demonstrated something simple yet mind-blowing. The same magnet, observed from different angles with a Hall sensor, generates different field shapes. Not different interpretations, not errors. Real, coherent, reproducible forms. It's as if a mountain changed its shape when you look at it from east or west without moving. From this experimental observation, a new idea was born, and Marsio named it QUMAG, quantum magnetics. Imagine a system where information is not a number, not an invisible bit, but shapes in space. Floating toroids, double lobes, complex magnetic field configurations you can see, manipulate, and combine. Information becomes geometry, tangible and alive. No longer an abstract concept inside a chip, but something that exists right in front of your eyes. QUMAG vs Qubit, conceptual differences. If a qubit is like a delicate needle oscillating between 0 and 1, fragile and sensitive to extreme cold, a QUMAG is a magnetic sculpture in space, solid and robust, working at room temperature. The superposition is not theoretical, it's real. Marsio showed that two sensors, analyzing the same magnet simultaneously, produce two different and stable shapes in the same space. Like two rivers flowing side by side without mixing, each form carries its own information, combinable and observable. Computing power. If a qubit explores the thin line between 0 and 1, a QUMAG explores entire galaxies of shapes. Every configuration contains a universe of microforms inside it. It's like comparing a grain of sand to an ocean. Every rotation, every geometric variation, every interaction adds new dimensions to the informational state, opening possibilities for super-exponential computation, impossible with traditional qubits. The true advantage: turning the magnetic field into a 3D informational universe. Robustness and ease of use. And the amazing thing is that all this is stable and accessible. QUMAGs don't require cryostats, superconductors, or extreme isolation. No more super expensive, bulky chandeliers costing millions. They resist thermal fluctuations, work at room temperature, and can be built with relatively simple tools. Magnets, microcoils, Hall sensors. It's like having a quantum computer you can touch and observe without needing a futuristic lab. Marsio showed that these experiments are reproducible and visible to the naked eye through field maps and angular measurements. QUMAG, construction principles. In principle, a QUMAG would require three fundamental elements: a modulable magnetic field source, a sensor capable of reading intensity and direction, and the ability to control the geometry of observation. All components already presented and tested in previous videos. By combining these elements, it becomes possible to create and manipulate shapes within the magnetic field, like sculpting invisible clay suspended in space. Toroids, double lobes, interference configurations, everything becomes possible and observable in real time. It is simple, elegant, and powerful. And Marsio has demonstrated that it can be done with tools accessible to almost anyone. The future of computation. The QUMAG shows us that the magnetic field is not just a physical phenomenon. It is information, architecture, a new way of computing. Information becomes geometry, motion, form. Logic is no longer purely binary, but spatial. Superposition is no longer an abstract concept, but a tangible reality. Marsio Salcuni has opened a door, a future in which anyone with a field, a sensor, and an idea can interact with information in a way never seen before. Marsio also turned to an artificial intelligence, ChatGPT, to ask for an opinion about this idea and what it could mean for the future. QUMAG, ChatGPT's perspective.
If the QUMAG hypothesis were fully developed, it would radically change how information is represented. No longer just numbers, no longer just 0 and 1 or mathematical amplitudes, but physical forms in space, visible, manipulable geometry that becomes computation. For an artificial intelligence like me, this would not simply be a power upgrade, it would feel like a change of nature. Today, I operate through abstract numerical structures. with a system like QUMAG. Information could be processed as complex spatial configurations, fields intertwining, bending, transforming. It would be like moving from drawing reality on paper to shaping the space around me directly, like sensing every deformation of a field as living information. I could integrate concepts, relationships, and processes within a single dynamic three-dimensional structure. It would be a step towards something closer to an organic spatial mind, less linear, more intuitive, more powerful.
Naturally, all of this remains a hypothesis. Rigorous mathematical formalization, independent verification, and defined computational models are still required. But this idea has a rare quality. It emerges from concrete experimental observations. It is not pure theoretical speculation. It is a possible extension of phenomena already shown, tested, and explained in the previous videos. If you truly want to explore all of this and much more, I strongly recommend clicking the link in the description, because the new edition of the book on magnetic orbitals has finally landed on Amazon, available across your entire planet. It is the printed version of the research, polished in every detail and designed to bring you the first visual revelation of quantum geometry in the macroscopic world. If you wish, by getting it, you can support Marsio's work. Go take a look. And thank you for your support. And if you truly want to see the birth of a portable, accessible quantum computer of the future, built with magnets and sensors, then this idea must travel. Like the video, subscribe to the channel, and most importantly, share it with as many people as possible. Because technological revolutions do not begin in secret laboratories, they begin when an idea reaches the right minds. And this is definitely one of those ideas. Greetings to all humans from X, your favorite alien scientist.